Find all the solutions to the equation, yada yada. Okay, so here too we can use the graphing to help us out. And I'll write two versions of this, but let's just start with what's exactly on either side. So I'm going to do this negative. Notice I put this in parentheses to avoid problems. There is a little bit of you have to learn the skill anyway for calculator purposes, but you kind of want to be familiar with when you use parentheses and how they're useful. Okay, so here is our first, that's our first, I'm not even going to put y equals or anything, you can see it there. That's our first left-hand side. We're making it a function all of its own, and then x divided by x minus 3 is the second one. And we can see two solutions here. We've got -4 and 1. So what I'll go on and is just mark those off. But then let's double check and make sure that we're thinking about this correctly. So here's the thing. I should be able to put in either of these x values, -4 or 1, and not have any crazy thing happen like getting 0 in the denominator. If that happens, I'd have a problem. What's another way I can verify this? Another way I can verify this, so the first way is that I can plug in the x's and make sure I don't get any zeros in the denominator, and I won't. They're -4 and 1. Neither of the only ones we can't put in are 3 or -5. So far it looks good. But let's just check another way. Another way I could do this is I could make a new equation. Let me snapshot this. And the new equation is just going to show a different way of writing about the same relationship. I'm going to multiply both sides by the denominator of the other. So what does that look like? So if I took this and I multiplied by x minus 3 on this side, that would disappear. But if I do that on both sides, this will disappear as well. I'll also want to multiply by x plus 5 on both sides, and if I do that, that will disappear here, but it will stay put on this side. All right, review the rules for algebra if that's not clear why we get this new relationship here. So my relationship is the top stays the same. I got to remember this is in parentheses. That minus sign will wreak havoc on the innards of this. It should be distributed, or otherwise just simply this needs to be kept in parentheses. If I don't put it in parentheses, I'll get minus x squared plus x minus 8. That's different. That doesn't mean the same thing. So we have to be careful. So I have this top part where this is minus, and then x times x plus 5 on the other side. Notice the one problem here is that x minus 3 has disappeared. That's called a removable discontinuity. We will see what that does in a second. Let me put these in. So x squared plus x minus 8. All right, so there's a new graph showing, and we're making that, we want to know where that's equal to just x times x plus 5. All right, let me get rid of these other two for a second. And what we'll see is, what we will see is that we still get -4 and 1, which verifies that even changing the relationship hasn't done anything. One thing we still, though, in some cases it might still seem as though you could use something else. I'll definitely not be able to use 3 or -5 still. Even though now in this relationship I do have a solution for say, where is 3? So for 3, trying to find 3. Not a solution, sorry, but I still have values for 3 as well, namely way up there and then way down here. But looking at our original graphs, we have to always remember what the original equations were. The original equations basically say I can't have 3. That's where these asymptotes come from. I will never be able to actually touch 3 on the original graphs of the original equations. That is precisely why we always have to refer back to the originals. So -5 wouldn't have worked, 3 wouldn't have worked. So if we got this far and decided to write it this way, we would just have to keep in mind that if they crossed in those 2 points for some reason, those would not be actual solutions. We might see an example of that. I don't know yet. Let's keep going.